Good evening, everyone. In our last video, we have seen very clearly what is mean by AVL tree, that is height balanced trees. Okay. Next and after that, how to insert the values into these AVL trees. Suppose if a balance factor is not satisfied, balance factor of any AVL tree should be always either 0 or -1 or +1. So apart from these three values, if we are getting any value, then we can say that node is imbalancing. Okay. So in such cases, we have to perform some rotations. For that, we have some special cases are there, like LL case is there. Okay. So how we can able to use this LL case and how to solve that problem, and LR case is what, how you can able to solve this problem, and RR case is what, how you can able to do this, and RL case. In LL and RR case, we have to do single rotation. In LL, opposite right rotation. In RR, opposite left rotation. In LR case, first we have to do left rotation and then right rotation. In RL case, first we have to do right rotation and then left rotation. So how you can able to do these rotations also, I think with the help of examples I explained very clearly in our last videos. Now we have to perform implementation of this AVL tree. Today completely we are going to talk about that implementation. Sir, we will see how we can able to implement that AVL tree. Okay. So now my requirement is, sir, I'm going to create a node first of all, because to insert the data, we need a node. Class node I am taking. This node class is having data field. Okay. In addition to that, I'm taking one more field called height, which represent height of the node. Then left pointer, anyway, it is already there. Right pointer is also there. Whenever we are creating a node with given data, then what will happen? That the current data will be assigned with the data which you have given. And so this dot left is always pointing to null, and this dot right is also always pointing to null. But what about the height of the tree? For any node, the height will be always 1, sir. This is nothing but a node. I think it is the same as like BST, but the only difference is nothing but this extra height attribute we got. Now, already we have seen binary tree, we have seen binary search tree. Now we are talking about AVL tree. So what functions we are going to take in this? To work with this, I'm taking static. One node will be their root. So inside the constructor, I'm going to give the initial value of root is nothing but null. Then static integer, there is one special method is there called height. If you pass any node, it will return height of the node. Okay, this method is going to return height of the node. Then static integer get balance. Okay, get balance. This is a method. If you pass any node, it will return what is the balance of that particular, that is nothing but balance factor of that particular node. Then so static void insert function I'm going to take, where you are going to supply some value, that value will be inserted, for which root is equal to, again I am calling insert function. For root we have to insert the value, so we need one more static function which will return a node after inserting the data to this particular node, this given value. Like this we have. Similar to this, delete function also we have to define. Sir, what is the delete function? Static void delete. Just I am going to provide the value. You need to check this value and you have to delete it. So root is equal to, I am going to delete. So from this tree, I need to delete this value. And for this also we have to take a static node delete function I am taking, which will receive a node and then integer the value which you want to delete. Like this we have. Sir, any other functions are required? I need to do balance, right? I need to do balance. Compulsory, you need balance also. Okay. Maybe I think for this deletion operation, it is the same like binary search tree, right? That's why you may required find in order successor. Okay. If you are passing any node, it should return. And even displaying is also is common activity, right? So static, it is going to return void. I'm going to take in order where you are going to give some node. Later we will implement these things. Then last methods which are very, very important. So static node, I'm going to write code for right rotation. We are going to pass a node called y. We have to do right rotation. So static node, we are going to implement left rotation where we are going to pass some node called x. That's all. These are the functions which are required for implementation purpose. Don't worry, step by step I will explain. So what is the purpose of height function? It has to return the height of the tree, height of the node which you have asked. Balance factor it will return. These two methods are for insert. These two methods for delete. When you are deleting, you may required in the third case, in order successor must be required, right? For that, I am taking this one. And in order to display the list, to display the tree. And while inserting and while performing delete operation, every node you have to check, is it satisfying AVL tree properties or not? That's why you may require some rotations. That's why I'm taking so left rotation and then right rotation. Now what we have to do, we need to create an AVL tree. I'm creating object for AVL tree. Then we have to work with various functions. Of course, that part we will discuss later. Can you please confirm, is this a skeleton? Is it clear for you people? Everyone, please confirm. Is the skeleton of this AVL tree? Is it clear for you people? Right, sir. Now I'm going to write code for one by one. Height. How to get the height? Sir, if the node which you have passed is null means we have to return height as 0. Otherwise, for that node, already we have HT attribute is there, which is going to return height. So it will return that height. Then, sir, get a balance. I need to get a balance factor of any node. How to get a balance factor? Array boss, if your node is equal to null, if your node is equal to null, then balance factor is 0. Otherwise, can you please return height of this left subtree minus so height of this right subtree? Like this I am passing. That's all. That is the formula, right? How to get balance factor. This is nothing but balance factor. How to get balance factor? Height of left subtree minus height of right subtree. Suppose if node is null, it will return 0. Like this, we have these two functions. Now, whenever you are calling insert function, it is going to call this internal function because for this root, we are going to add. How this insert function is going to work? We will check the node which you have given is null means if it is not having any node, that means root node. In such cases, I am going to return new node of the value which you have given. Okay. First case, what is the first case? If there is no root node in your tree, the first tree you are creating, first node you are inserting, then the node which you have inserted will become root node. Okay, right. Let us assume, sir, I want to insert. Okay, I want to insert something like 10 20 30. 10 20 30. Sir, first I inserted 10. Sir, is the root node is there? No. Then the node which you have created, it will be created like this. Remember carefully, it will return that node. That node is referencing to root. This is nothing but root. Okay, fine. Now I want to insert 20. I want to insert 20. Sir, now 20 is the value. For root node, we have to attach. Is your root node is equal to null? Is the node is null? Because node is root. Is root is null? No. Then what we have to check? You need to check the value. Sir, if the value whatever you have given, is it less than node dot left dot, okay, node dot data, like this. So the value which I want to insert is 20. Is it less than 10? No. Then what will happen? If it is less than 10, suppose I want to insert 5, your node is there, right? Its left pointer is pointing, so insert of node dot left comma value. Anyway, I will explain this case for right subtree, don't worry. Suppose consider I want to insert 5, so we are passing 5 first. We are inserting 5 for this root. Now root will become root, value will become 5. Is your node is equal to null? Is root is equal to null? No. Then is the value which you have given 5, is it less than node dot data? What is the node? What is the node that you have passed root? Sir, it is less than. Then insert. We are calling insert function by passing node dot left. Node dot left is what? Null. So that will become node. Sir, it is equal to null. Then what will happen? It will create a new node. It will create a new node and the value is nothing but 5. This will be returned to who? Node dot left. This link will be established now. Okay, like that we are going to get. So I'm removing all these things. So clear with this 5. Now, sir, I'm inserting. Okay, I want to take another function. Else, suppose if it is not satisfied, the value which you are giving is greater than node dot data. Then your node dot right will become insert function I am calling by passing node dot right comma value. Otherwise return that node. Okay. Now listen my words carefully. Now I want to insert 20, sir. Is node is equal to null? No. Is 20 is less than 10? No. Is 20 is greater than 10? Yes. It will create a new node for nodes right field. So that link will be attached now and that will be returned for this. As of now, we are not came out from the function. Remember carefully. So return type for this insert function is node. There are only two cases where it will return. It will return a new node. This will happen if there is no nodes in the tree. And the value which you are passing, suppose consider I want to insert 20 again. Is the node is equal to null? No. Whatever value that you are passing 20, is it less than root dot data? No. Is the value is greater than root dot data? Root dot data? Yes. Then it will come to the right subtree. Already node is there. Sir, is the value is less than data? No. Is the value is greater than data? No. Then it will return that node itself. 20 itself written. That means no new node is going to create when you are sending duplicates. So this case is what for? Duplicate case. Duplicate values or duplicate nodes. So it won't execute. It will simply return. So till now, that particular what you can call the flow of control is in this function only. Okay, the function is not terminated. When the function will terminated, if it is our normal tree, then we are going to return. Since it is not a normal tree, the function is available in this itself. Okay, in this itself we have that function. So if you return a node, then it will be written. But as of now, here I am not returning. When it will be written? If duplicate function came. Okay, sir, still the code is there. Now we have to check for balancing. We have to check for balancing. Can you please confirm up to this? Is it clear? Up to this, is it clear? Right. Now observe carefully. I am doing balancing now. Sir, what we have to check? What we have to check here is array. Whatever node that you have inserted, its height will become 1 plus math dot max of, so height of that node left subtree, comma, so height of that node right subtree. Try to calculate height of this node and add plus 1. So which node we inserted latestly? This one. For this one, we are checking the height. What will be your height? What will be your height? This height is already we know. Its height is nothing but 1. I am not talking about a balance factor. Its height is nothing but 1, because at the time of creation, by default, height will be 1. So while creating this node also, what is the height of this node? 1. Now node dot height will become 1 plus. So math dot max of left subtree height. What is the left subtree height? 0. Because null, right? Right subtree height null, because sorry, empty, 0. Because height function will return 0 when node is null. Okay, sir, now we got this value as a 0 comma 0 in this maximum, that is 0 plus 1, that will be height of node. Of course, it is already 1, it will be updated with 1. Okay, now maybe it is a recursion call, right? After completion of it may call for root node. For root node, what is the height? Height of left subtree, which is nothing but 0. Height of right subtree, 1. Among these maximum, it is 1. 1 plus, so current node height is 1, so it will become 2. Now this height is updated to 2, sir. Okay, this height is updated to 2. Like this we have. Like this, for every node, it will update height for every tree, sir. That's why here we are not returning the value directly. So if you are passing a new node, it will update. I mean, first time it will create the node. Second time onwards, after creation and assigning to the left, it will be there in the same. Okay, so node dot left, we are returning this to node dot left. And for node, it will execute, right? That's why it is going to calculate. Like for every tree, these instructions are going to execute. Okay, I assigned height. Then what is your requirement? That is the main task concept. So integer balance factor I'm getting. Already we have function, right? Get balance of this node. Get balance of this node. So first time it is going to call for this 20. What is the balance of this node? What is the balance of this node? Sir, we called get balance function, right? So if node is equal to null, is node is equal to null? No. Then what will happen? Height of left subtree minus height of right subtree. Left subtree height is nothing but 0. Right subtree height is nothing but 0. 0 minus 0 will become 0. 0 is nothing but a balance factor for this. Okay. Now, what is our next activity? What is our next activity? I am going to, okay, I am going to check balance factor for root node. It is completed, right? Then it will execute for root node. For calculating root node, what is the balance factor? So it is going to execute again. Height of node dot left. Is there any node dot left? No. So height will become 0. What is the height of right subtree? Node dot right. What is the height of node? So right node 1. So 1, 0 minus 1. Sir, it will become what? Minus 1. This is nothing but a balance factor. I am writing balance factor directly. I am writing height within square brackets. That is the indication. Like this, after inserting two nodes, this is the situation. Sir, after inserting this, there are 4 cases. So if first condition is satisfied, what we are doing, if second condition satisfied, what we are doing, if third condition satisfied, what we are doing, if fourth condition is satisfied, what we are doing. After doing all these activities, finally we are going to return that node where the program is going to stop, that is insert function is going to stop. What is these cases? I will explain, because as of now I have written only 2 successful nodes. Once if you are getting imbalance, then I will write the code. Okay, sir, clear up to this? Please confirm. Clear up to this? Please confirm. Yes, now listen carefully. Very, very important step I am explaining now. Sir, please put concentration. Now I want to insert 30, sir. I want to insert 30. For root node, I am inserting 30. Is your root node is null? No. So the value which you are sending 30, is it less than root node data? No. The value which you are inserting, is it greater than root node data? Yes. Then it will try to insert a node at a right node. Now, sir, root right is there, right? That is nothing but a 20. For this 20 node, I want to insert 30. So again, it will call. See, whenever it is calling this one more time, for root node, these operations will execute. For root node, these operations will execute again. Now we are passing 30 as a one more time. So now this node will become 10's right child. That is nothing but 20. Is that node is not existed? No. Sir, what is the value that you are trying to insert 30? Is it less than the passed node data, which is nothing but 20? No. Then is that 30 is greater than 20? Yes. Now we are trying to insert the data. We are trying to insert the data. Node dot right. This is the node right. For this right field, we are adding that value. What is that value? Sir, value is nothing but 30. It will be added. Once if 30 is added, by default, one more property is there. What is the height of this node? 1. Then, okay, up to this task completed. Up to this task completed. Now, it is going to return which value? Whatever node it is inserted, that node it will return. That will be assigned to right. Now, we have node, root node, we have to trace one more time. And its left tree, we have to trace one more time. Now, the newly created node, still the control is there. Now, we have to do that. 3 operations are pending. Now, I am doing this in reverse direction. Now, observe carefully. Anyway, node got created. Now we have to check few properties. What are those properties? Array sir, can you please update height of the tree? Node dot height. What is the height? This one 1 plus math dot max of node dot left. Left node is not there, hence 0. Right node is not there, 0. So 1 plus max among these two is 0 only. So it will become 1. Already it is 1. I'm not going to update. Balance factor. What is the balance factor for this? So node, I'm going to send this node. It will return balance factor. Height of left subtree 0. Height of right subtree 0. So balance factor is 0. Sir, these conditions, I'm writing 4 conditions, right? These conditions are going to check whether your balance factor, is it greater than 0? Is it greater than 0? Your balance factor, is it less than -1? Again, one more condition for greater than 1 and one more condition for less than -1. Of course, we will see later. Sir, is this balance factor is greater than 1? Greater than 1? Less than -1? Less than -1? No, that means it is balanced. So I have drawn 3 lines, right? In this first line execution completed. So which line is pending now? Which line is pending? This 20 line is pending. Now we are going to check for this. What is a node dot height? 1 plus math dot max of height of left subtree 0. Height of right subtree, it is 1, right? So what will happen? 1 plus 1, it is nothing but a 2. So this height will be updated to 2, sir. This height will be updated to 2. Sir, what about balance factor? What about balance factor? Get balance. Height of left subtree 0 minus height of right subtree 1. Sir, what is the balance factor? It is nothing but -1. It is not 0. It is nothing but -1. Now, is this balance factor? Is it greater than 1? No. Is it less than -1? No. Greater than 1? No. Less than -1? No. So we are not required to do the balance. And this one got completed. Okay. Finish. Now, at last, we have to check these activities. These activities for root node. So root node. What is the height? 1 plus math dot max of left subtree height. No elements are there. right subtree height. What is the right subtree height? 2. So 1 plus 2. What is the height here? 3. So previously it was 2. Now we have to update that to 3, sir. Now we have to update that to 3. Now, okay. Sir, what about the balance factor? Height of left subtree 0 minus height of right subtree. Sir, 3, right? Okay. 3 or 2? 2. Sir, what is the balance factor we are going to get? Minus 2. The balance factor, this one is nothing but minus 2. Like this we are getting. Okay. Now here the situation came. Observe carefully. Is it greater than 1? No. Is it less than minus 1? Yes. So here that means that that is unbalanced. The tree is unbalanced. Here we have to write the code. For this I explained the rotations. For this I explained the rotations. But how to do that rotations, I will explain from the diagram. I think it is very clear for you people up to this. Can you please confirm, guys? Up to this, do you have any doubts, friends? Because I am taking so much of effort to explain this, try to understand. Is it clear up to this? Please confirm everyone. Clear up to this? Everyone has to respond, sir. Right. Now see here, sir, can you please tell me it is which case? It is which case? It is unbalanced, right? Which case? We have 4 cases are there. LL, RR, LR, RL. Which case it is? Which case it is? Very good. Everyone is telling it is nothing but RR case. Okay. Not a triple R. Okay. RR case. Somewhere I drawn the diagram. Yeah. This is the RR case, right? Which rotation is required here? Can you please see the diagram and tell me which rotation we have to do? Which rotation we have to do? Left rotation. Very good. We have to do left rotation. Sir, by seeing the diagram, we came to conclusion that we have to do left rotation. But how my system can understand? How my system can understand? How we can say it is left rotation? How we can say it is left rotation? Sir, my balance factor of this main node, which is the main node here, this node, this is the main node. Listen carefully. This is my main node. Here imbalancing is occurred. So this main node is there. This node balance factor is less than minus 1. But you are directly telling we have to do left rotation. We have to do left rotation of which node? The current node, that is nothing but root. And after this, whatever tree we are going to get, I'm going to return. Sir, one more way is there for getting balance factor minus 1. If you see the diagram, here imbalancing is occurred. So here also there is a chance, right, getting minus 1 imbalancing. Okay, here also there is a chance. Okay, here also there is a chance minus 2. But how you can able to tell it is RL case, it is RR case? Sir, by using some small terminology. What is that terminology is here I am going to write. Sir, the value which you have inserted, that is 30. So is it greater than node dot write data, right? So this one is there, right? This one. So this value 30, is it greater than node is this one? It's right node is nothing but 20. So data is nothing but 20. Yes, it is greater. That means in this, suppose here if you have 15 is there, then what will happen? Sir, the node which we inserted is 15. Is it greater than node write data 20? Condition not satisfied. That means it is not left rotation. It is somewhere else. It is some other node. That we will discuss later. Okay, that we will discuss later. So that means what? My balance factor is less than, okay, less than minus 1. And if the value which you are given is less than node dot write dot data. Sir, can you please tell me? Then it will comes under which rotation? Please confirm everyone. So it is left subtree and it is right subtree. Which notation? LR. LR, right? If it is LR, what we have to do? First left rotation. Okay, first left rotation. Left rotation or right rotation? Is it LR? Sorry, it is right subtree, it is left. RL. RL means what? First we have to do right rotation and then left rotation. Two rotations are required there. Two rotations are required there. Okay. This is nothing but what we have. Of course, we don't have this yellow color terminology now. Just we are talking about white color terminology. So this is nothing but the code what we have. Sir, we are doing written left rotation of node. We are going to do left rotation. Sir, we need to fill that left rotation. Okay. How you can able to do this left rotation? I'm going to write code for this now. Okay, maybe just assume that's all. I'm going to do the code now. Sir, clear up to this? Clear up to this? Please confirm everyone. Right. Sir, see the diagram again. We have to do left rotation. In this left rotation, observe this diagram and this diagram. Observe this diagram and this diagram. Where we got imbalancing? Where we got imbalancing? This is, I'm considering this node as X. I'm considering this node as X. So that means in the diagram, in this diagram, I'm considering this node as X. Okay, right, clear. This is nothing but X what we have. This is nothing but X. Okay, fine. Then, sir, what I am going to do is, I'm going to write code here. Sir, I'm going to take two special nodes. One is nothing but Y. Y is nothing but X dot right. And I'm taking one temporary node, which is nothing but Y dot left. Like this I'm taking. Now observe from the diagram. X dot right 20. This will become Y. Y dot left, which is nothing but null. This one will become temporary node. Same thing I am writing in the diagram. Same thing. So X dot right will become Y. Okay. So this Y dot left will become temporary. Sir, we have three nodes are there. A, B, and then T. X, Y, and then T. Among these three, which one will become root node? B, right? That means Y will become root node. Y will become root node. If Y is the root node, what is the left child of Y? It should be A. So Y left child should become X. Y dot left should will become X. Okay. What about Y right child? Y right child? Sir, we are not required to disturb that because Y right child is as usual link is there. We are not required to delete that link. Okay. Sir, then what I am going to do is X right child. Y left child is nothing but we have assigned X, then X right child. Okay, X right child. Already it is there B, right? This link we have to break up. So in this place, I'm going to take T because if you observe for A, right subtree will become BL. BL is located in T. That means what we have to do? Sir, X dot right will become T, sir. Now in this tree, you can see where I'm going to do balancing. I'm writing with a diagram. Sir, node Y is equal to X dot Y. Okay, so this is X. So X dot right will become Y. Okay, and then Y left, that is nothing but T. Now Y left is there, right? Y left is there. It will become X. What is the X? 10. So that means this link is gone. Now x dot right is there, right? X dot right. This field is empty now. X dot right. This field is empty now. That will be assigned to null. Null means what? Empty. So that your new tree will become. So that your new tree will become like this. Clear? Is it our required data or not? Yes. But again, we have to update the heights also, right? Because so many modifications we have done, we need to update. Which nodes we updated? Only two nodes, x and then y. So I'm going to change x dot height is equal to math dot max of, anyway links are there. Try to calculate left side height at the same time. Try to calculate right side height. Okay. So with that, it will give perfect height. Then similarly, y node height I'm calculating by taking math dot max of. So height of y dot left subtree, comma height of y dot right subtree, like this. Sir, everything updated. Which node we have to return? So return y. We have to return y node because already x got this one. We have to return y node. Okay, we have to return y node. That's all. This is nothing but how you can able to do left rotation. And the same thing we have to apply for right node also. I think this entire thing is the same here. Okay, for right rotation also we have to do same thing, but maybe these two instructions we are going to change. That part I will explain. So here we need to return x because I'm going to use different representations there. Anyway, I will fill that 4 lines code. Okay, here we have to write line number 1. So here we have to write line number 2, and here we have to write line number 3, and here we have to write line number 4. We know what are those 4 lines. Okay, but we will update that later once if such type of situation occurs. Sir, I think you people got at least now clarity. Sir, after doing this rotation, now see what is the height. What is the height previously? I think this is nothing but y, right? I think if the diagram is there, it will be good. What is the name of this one? 20 name is what? I forgot. Is it x or y? Can anyone please tell me, is it x or y? I think it is y, right? It is x, correct? Yes. Now, what about heights? You can cross check. What about heights? Yeah, what about heights? This is already, it is there. Its height is 1. I'm going to talk about height. It is nothing but 1. And the balance factor will become 0. Now, x node height I want to calculate. What is the height? Height of left subtree 0, height of right subtree 0. So whenever we are calling these, I think height of x dot left. So height of x dot left, height of x dot left. So it is going to return height of this left subtree, which is nothing but 0. One second, somewhere I think we need to add +1 also, right? Okay. Now left subtree height is 0 comma 0. Max is nothing but 0. And this one height is nothing but 1. Like this we are going to get. What is the height of y? 1 plus. So height of left subtree is 1. Height of right subtree is also 1. So 1 comma 1 max is nothing but no. Height of left subtree is nothing but 1. Height of right subtree is nothing but 1. Max is nothing but 1. 1 plus 1 means this height is nothing but 2. Like this we are going to get. So of course balance factor here we are not going to calculate. Where we calculate this balance factor? So here after this situation we are going to execute for next node. We are going to calculate for next node. There we will calculate a balance factor for every node. If a balance factor is good, simply it is going to return. So balance factor is correct, right? We are not required to calculate one more time. This is nothing but the updated tree, what we are going to get for this. Can you please confirm? Is this a small code? Is it clear for you people? Is it clear for you people? Ayo, no response from your side. Slowly you need to calculate, then only you people will get it. Right. So anyway, already I have written code. Okay, already I have written code for left rotate, right? Sorry, right, left rotate. Now we will write code for right rotate. We will write code for right rotate. Sir, right rotate means from which diagram we can take? This is left. This is left rotate. So I will take here. This will become right rotate. If it is the right rotate, so what are the names that we can provide for here? What are the names that we can give here? Okay, so what are the names that we can provide for this? Consider while calling, I'm going to give node as a y. That means here imbalancing is going to occur. This will become y. Okay, so now what we have to do? Right rotate means, so y left child will become x, y left child will become x. Here I am going to take line number 1. I am replacing node x is equal to, so what is the node x? Y left child, y dot left I am doing. And what about next one? Node temp will become, so here we have to get changes where, sir? I think this br is going to change, right? Because everything will come. If you see, C will become left child of a B. Yes. And A we have to change this link, and AR will become right child. So CR is as it is available. The only modification BR. That's why BR we have to give the name. What name I am giving here? For this I am giving T. For this I am giving T. That means what? So T will become X. T will become X, which child? Right child. After that, so which thing we have to do modification here? If you observe, sir, B will become root node. That is nothing but X. Okay. So your X left is already C. Your X right will become Y. So X dot right will become Y, sir. Then, sir, what about T? What about T? So this T value will become where TR is nothing, T is nothing but BR. BR is left subtree to A. A is nothing but which node? Y in our diagram. So Y left child will become T, sir. Y left child will become T. That's all. This is nothing but what rotations we have to do for for right rotation. Okay. So this is nothing but what we have to do for left rotation and right rotation. Only we have these two rotations only. But in LL, we will do right rotation. In RR, we will do only left rotation. But if you take LR, we will call left rotation. On that result, we are going to call right rotation. Like this, two rotation functions we are going to call. Okay. Sir, is these two functions, left rotate and right rotate, is it clear for you people? Right. So next one, what we have here is, sir, we need to complete this insert function. Suppose if a balance factor is greater than 1, if a balance factor is greater than 1, and the value which you are searching, the value which you are searching is less than node dot left dot data. Okay, so by inserting the value, we got balance factor is greater than 1, and the value which you are inserting so is less than node left data. That means what, sir? Which rotation we have to do here? So consider the node is like this, the node is like this, the node is like this. Here we got imbalancing. That means the value which you have inserted here, it is, I mean, the value which you have inserted here, it is less than node left child to left. If it is means what, which rotation we have to do? Right, and this case will become LL. So we have to do right rotation, opposite for this. So in this case, what happened? Like this, we have the node which we have inserted, this value is greater than node right child data. Okay, node right child data, great, right? In such cases we have done left rotation, but in this case we have to do right rotation. Let us do that right rotation code here. So very simple, we have to return left rotation, no, sorry, right rotation of that particular node. So this is nothing but which cases are LL case, and this one will become which cases are RR case. And what about this one, sir? Balance factor is greater than 0, balance factor is greater than 1, greater than 1, and the value which you have inserted, the value which you have inserted, it is greater than node dot left dot data. Okay, so assume, I think what diagram I can write here, let us check. So this is one case, right? For this left and for this right, this is one case. Another case is for this right and for this left, this is another case. So the value which you have inserted, whether it may be this one or this one, so it is less than, means in this case, so the value which you have inserted is less than, this is the node, right? It's a right child data. That means this one will comes under which case? Yeah, RL case, RL case. This one will become RL case. Okay, what about this one? Definitely it is LR case, LR case. If you want, you can see from the diagram. Sir, the value which you have inserted, it is yeah, I think the value which you have inserted, this will become RL case, right? And this will become LR case. Is it correct? Let me check. The value which you have inserted is greater than node left data, greater than, that means LR case. So if it is LR case, first which rotation we have to apply on that node? Okay, on that node dot left. Okay, on that node left, we are going to call which rotation? First we have to call left rotation on that node dot left. After this, we have to call right rotation on that node. First we have to do left rotation of this one, and then we have to do right rotation of this. Sir, what about in this case? What about in this case? So node dot right will become, okay, right rotation of node dot right. After this, we have to return left rotation. After this, we have to do left rotation of node. That's all. So these are nothing but the rotations code what we have here. Okay, sir, we have seen how to insert the data and how you can able to check balance factor, how you can able to check a proper balance factor. Okay, I think it is clear up to this, but I will put these things in a comment because delete operation we will see later. What about in order? What about in order? So I think we are not required to talk about this in order. We know already code. If your node is equal to null, then I'm going to return. I'm going to return. Otherwise, what will happen? So in order of, I'm going to call node dot left. After that, I will try to print system dot out dot print node dot data followed by some space I need to provide. After that, again, I will call in order of node dot right. You know very well about this code. We are not required to see. And rotations are clear. Now we have to check, sir. Now we have to write the code. Sir, first let me check is the code is going to compile or not, because if any syntactical mistakes are there, we need to verify. Yeah, there is no syntactical mistake. Now my task is nothing but what, sir? We have to insert the nodes and we have to check. We know very well already we have seen, sir, AVL tree dot insert function I am calling. Sir, I'm going to send a 10. I'm going to send a 10. Sir, immediately it will call this insert function. So we are sending a value. That value will be attached to root node. We are going to call is node is equal to null. Yes. Then it will create a new node. Since it is written, it will return. So balance factor, all these things it won't check, because that is the only node what we have. Now let me print. So AVL tree dot in order. In order I am going to call. Okay. Sir, let me check really whether that data got inserted or not. We will cross check. Sir, method in order in a class cannot be applied. What we have to do here, obj dot, we need to send a root node because it will be executed for root node. We got a 10. Okay, fine. Now observe carefully. I am trying to insert AVL tree dot. Again, I am trying to insert 20. Of course, here no problem. Successfully, it is going to insert 10, 20. Okay. So listen carefully, friends. First, I inserted a 10. Now I am going to insert a 20. Sir, now I am going to insert a 30. Okay, now I am going to insert a 30. So let us see how it will be. I am going to insert 30, then we will discuss about the outputs. AVL tree dot. So insert of I am taking 30. 30. Now let us execute. Sir, what output we got? What output we got? If you observe, so 10, 20, 30. So maybe in our these discussions, this is the in order for this tree, right? But what is the in order for this? Left subtree, nothing. Root value, that is nothing but a 10. Left subtree, nothing. Then root node is nothing but a 20, of course. So here we are getting same in order. Sir, is it correct? Left subtree, root node, right subtree. Again, right subtree, left subtree, root node. Okay, unfortunately, it is same. Okay, leave it. Now we will add a few more nodes and then we will decide. Okay, now what I want to insert here is I want to insert one more node, AVL tree dot. I want to insert 40. I want to insert 40. Sir, what will happen? This is imbalancing. So 20 will come here and then 10 will come here and then 30 will come here. Now balance is good. Now 40 will come here. Is it imbalancing? So balance factor is 0. Here a balance factor will become -1. So here 1 minus 2 minus 1. Yes, perfect. There is no issue here. There is no issue here. Now I will try to insert one more item, which is nothing but AVL tree dot. So insert of 50. I'm trying to insert 50. So where this 50 is going to insert? So here it will be inserted. Here it will be inserted. Okay. Now what will be our data? Sir, compulsory rotation is required by inserting this. Balance factor is 0. And here balance factor will become 0 minus 1 minus 1 0 minus 1 minus 1, and here 0 minus 2 will become -2 is the balance factor. Here imbalancing is occurring, so 20 will become root node. For a right subtree it will become 40. For this left subtree will become 30. For this left subtree will become 50, and for this left subtree will become 10. Like this we are going to get. Okay. So let us check whether we are getting correct output or not. Whether we are getting correct output or not. So 10, 20, 30, 40, 50. Like this we are getting. Okay. Now we will insert one more node. AVL tree dot. So insert of, I want to insert 25. Where this 25 is going to be added? So it is greater than 20, less than 40. So 30, is it greater than or less than? Less than. So here imbalancing will come. Here imbalancing will come. So which one will become root node? 30. Okay. So 20 is nothing but root node. 10 is a left child. and here your right child will become 30 or 25. So this is LL, right? So LL means can you please confirm? Is it LL only, right? If you rotate, we have to rotate towards right. 30 will become root node. So 30 will become root node for 30. So 30 will become root node. 20 will become left subtree. For this, right subtree will become 50. Okay. 40 will become left subtree for this, right? Now check the balance. So 0, 0, it is nothing but a plus 1. 1 minus 2, it will become minus 1. Okay. It will become 0. So 1 minus 1, 2, 3. So minus 2. Here imbalancing is occurring. And again we have to rotate here. It will become LR. LR. LR means first we have to do left rotation. So left rotation means 40. So 30, 50. Root node itself is going to change, right? Which will become root node? Already we practiced this example. Oh, we have seen this example. Rotation is RL. Yeah, RL. If rotation is RL, first we have to do right rotation. Right rotation means what? This one, right? So your 30 will be there and your 40 will come and then 50. Right rotation. This is which case? Like this? Yes, correct only. Then after this we have to do which rotation? Left rotation. If you do left rotation, your 40 will become root node, 30 will become left child, 50 will become right child. So already 20 is there, 20 will become left child of this. So 20, 25, 25 will become left child, 10, and here it will become 40. So for this 30, for this 25, for this 50. So balance factor 0, for this one plus 1, 0, for this 2 minus 1, 1, and for this we are going to get 0. So 1 minus 1, 2, 3, minus 2. Here imbalancing is going to occur. So this one is nothing but right child, right. Again we have to do the rotation. Okay, I will do one thing. Yeah, I will do one thing. Yesterday I have given some link, right? According to that we will trace. Okay, so that we can get somewhat clarity. At least we will check. Yes. What is the first inserted node? Can you please tell me? Up to 50, right? So 10. And second one is nothing but a 20. And third one is nothing but a 30. And the fourth one is nothing but a 40. Next one is nothing but a 50. Next one is nothing but 25, last one. Left rotation it is doing. Then like this 30, 30, maybe it is correct or not. We need to cross check. So what is the in order for this? What is the in order for this? I'm typing in the chart window. Can you please cross check? 10. So after that 20, after that 25, okay. After that 30. So after that 40, after that 50. Is it correct? Correct, right? Now let me execute this code, but I have a doubt. Okay, no problem. Let me execute this code in order. So I am expecting 10, 20, 25, 30, 40, and then 50. Let me execute this, whether it is coming or not. 10, 25, 10, 20, 25, 30, 40, 50. But I have a small doubt, sir. So first inserted node is 10, then 20, then 30, then 40, then 50, then 25. Is it different of in order? Oh, sorry. Try to calculate in order for this. Left subtree, nothing is there. So 10. So 20 left subtree, nothing is there. 20. Then 30 left subtree is there. 25. And then 30 left subtree is not there. 40. So same in order. That is the problem. So what is the pre-order for this? Can you please cross check what is the pre-order? Pre-order means root first. So 10. Next left subtree, nothing is there. Right subtree, left subtree, root node, left subtree is not there. Right subtree, then again it is not having any left subtree. So root node, left subtree is not there. Right subtree is there. Right subtree is again a tree. In this root node is nothing but a 30. Left subtree is nothing but a 25. Right subtree again a tree. Left node is not there. Right node is nothing but what we have 50. Then root node is nothing but 40. No, 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 no. 1 second. Pre means first root, right? Up to 30, okay. Then 25 left subtree. Right subtree is again a tree. In this root node, first we have to visit 40. Left subtree is not there. Right subtree is nothing but 50. Sir, is it correct? Can you please tell me pre-order 10, 20, 30, 25, 40, 50. Swapnil, correct, right? Yeah, just keep it in mind, this one. Now, sir, what is the node that we have got created in this diagram? Can you please tell me what is the in order pre-order for this? What is the pre-order for this? Can you please calculate? So pre-order root node will become 30, left subtree again 20. So 10, 25, again left subtree, root node 40, left subtree is not there. So 30, 20, 10, 25, 40, 50. Correct, right, Vishal? Yes. Yeah. So now we will get the clarity, sir. Whether the program is correct or not, we will get the clarity. Now I'm going to print. So AVL tree dot pre-order of that obj dot root node I'm going to pass. Sir, what is our expected output? Expected output. Expected output is nothing but what? 1 second. 10, 20, 30, 25, 40. Is it correct? Is this one is correct? So as per diagram, as per BST, okay, according to BST, so what is order that we are going to get? Vishal, you have sent that one only, right? Is it correct? Right. We will cross check, but we need to implement a pre-order, right? We need to implement a pre-order. So pre-order means first we have to print root node dot data. So then we have to call for left subtree and then right subtree. Okay. Now we will check, sir, whether we are getting proper output or not. Whether we are getting proper output or not. Okay. So better I will, yeah. So better I will execute this code. Any syntactical mistake? No. So 30, 20, 10. 30, 20, 10. Okay. So 25, 40, 50. 30, 20, 10, 25, 40, 50. That means it is according to the BST it is giving. But as per this, no, as per BST, right? Sir, I got confused. According to this, 30 should be the first element. This is our output, what we have to get. Clear, right? Sir, is it giving correct output or not? Yes. As per BST, my output is nothing but what? As per my BST, the output is 10, 20, something like this we have. Yes, this one. Correct. Because if you see, first we inserted 10, then 20, so then 30, then 40, then 50, then 25. So pre-order means what? 10. Then here itself we got the clarity. Got it? So I think you people got clear clarity about how we can able to insert an element into binary search tree. Sir, can you please confirm? Do you have any doubts about this? Yes, please confirm. Any doubts up to this? Maybe you need a lot of practice, sir. You need a lot of practice. Okay, right. So for deletion also same code we have to write. Anyway, I will give that code in the running notes, but you practice, sir, because delete operation is the same like a binary search tree, but the only thing is after deletion we have to check balance factor of every node. If it is not balancing, then we have to perform rotations. Anyway, I will put that code in our running notes, don't worry. So you people will get a clarity, right? So clear up to this? This is nothing but what we have AVL tree, sir. Search operation and delete operation, I will write the code there. Okay. So with this, we have seen AVL tree. Sir, tomorrow we have classes there. Okay. So tomorrow we have classes there. There I'm going to talk about dynamic, sorry, not a dynamic, backtracking. A beautiful applications we are going to cover. Please don't miss the class. So same link you have to use. So same link we have to use. So where I'm going to take backtracking, a most important and a bit tricky and confusion topic. The session is going to start at 6 p.m. So 6 p.m. to 8 p.m. 2 hours session I am going to take. Of course, somewhat tricky and something will be very useful. Okay. Don't miss the class. I am going to finish that backtracking tomorrow in this 2 or 2.5 hours. Please be prepared for that. Okay. Right, sir. So thank you. We will meet for the continuation tomorrow at 6 p.m. The same link you have to use. Okay. Yeah. Thank you, guys.